Here we're given that secant theta is 4, and then we have to figure out everything else. So again, whenever you're asked to find your trig ratios, it's probably going to be a triangle question. How do we draw that triangle, and what we have to think about? We have to use all of our knowledge about trigonometry to do that. So first of all, when you have secant theta is equal to 4, what have you learned about secant? It's the reciprocal of cosine. So if secant theta is equal to 4, then cos of theta is 1 over 4. So our first job, since we know we want to draw a triangle, we want to draw that triangle correctly, and then we're going to want to label our reference angle. So if I was going to draw this angle theta, and I know cos of theta is 1/4, where would I draw it? Or maybe there's more than one place I could draw it. Quadrant 1. Why quadrant 1? Yes, it will be in quadrant 1. Good. But why? Yeah, it's going to be quadrant 1 because of your cast rule. Remember, your cast rule says where things are positive. The A means all of them are positive. The S in quadrant 2 says only sine is positive in quadrant 2. The other ones, cos and tangent, are negative. Cos of theta is the adjacent over the hypotenuse. It could also be in quadrant 4, right? Yeah. And so your angle theta could also be this one in quadrant 4. You have two possibilities. I'm going to draw them both because that's going to help us in B, but what Jake mentioned is true. If we look in this question says only look between 0 and 180. And so in part A, they're saying only look in quadrant 1 and quadrant 2. So we're only going to consider this one for part A. With that considered in part A, once we've drawn our angle, and once we've drawn the terminal side of our angle, we can make a triangle. So I can draw this straight down here, and if we did this one over here, I would draw this straight up over here, making a right angle triangle. And on both of those triangles, we have a reference angle. And the unique thing about that reference angle is going to be the same for that triangle in quadrant 1 and the same for that triangle in quadrant 4. Because we can now label some sides of our triangle. If we know cos of theta is adjacent over hypotenuse, and I've got my reference angle labeled there, I can now say I know this side is the adjacent side, this side is my hypotenuse. This side is the adjacent, this side is my hypotenuse, and once you have that, a squared plus b squared equals c squared comes into play. And mental math, this is going to be square root of 17, 15, both good answers. To be careful here because the 4 is the hypotenuse, right? So it'll be the 15. You have your triangle labeled. Can we find the other trig ratios? Which ones haven't we done? We haven't done sine and tan or their reciprocals. So if I write, what's sine of theta going to equal? What's tan of theta going to equal? And the reciprocals, what's cosecant of theta going to equal? And cotangent of theta. Sine, opposite over hypotenuse. Tangent, opposite over adjacent. Cosecant will then be the reciprocal and cotangent will also be the reciprocal. How come they're all positive? Because we're looking in quadrant 1. For part A, we're only looking at this one right here. And since it's in quadrant 1, sine, cos, and tan will all be positive, and as a result, the reciprocals will all be positive as well. So just this little bit of information right here. You know how I said yesterday you get a little bit of information, boom, the question opens up big? With this little bit of information right here, that tells us all of this. And so we now have all of this as a tool that we can solve for anything else. And because we know all of this, we can also figure out what every angle is here. Of course, in part B, that's what they're asking. We're going to find the angle theta. And not only do we have to find the regular angle theta, this one here for quadrant 1, and this one in quadrant 4, because that would be going once around the circle, which would be going from 0 to 360 degrees. But they tell us they want all the angles between negative 360 and 360. So in other words, they're looking for every coterminal angle between negative 360 and 360 that ends either here in quadrant 1 or here in quadrant 4. Can you see from 0 to 360 there's going to be 2 answers? Can you see in the negative direction from 0 to negative 360? There's going to be 2 more. So first of all, we need to find that reference angle. So for part B, we start out by finding our reference angle. And you can do that just by using the triangle. If you look at that triangle, you've got your reference angle, you've got 3 sides labeled. You could choose to use sine, cos, or tan to figure it out. If I look at the values, I'd probably choose cos just because they all have whole numbers. I'd probably also choose cos because that was one of the first things that we figured out. So there's less chance of us having made a little mistake along the way. So if we know that cos of theta is equal to 1 over 4, or cos of our reference angle is equal to 1 over 4, how do you find your reference angle? What would you do on your calculator? Cos inverse. So you know how we were talking about inverses in the first unit? Well, here's a cos inverse. It undoes cos. So what it does is it works backwards and says if we know that cos of the reference angle is 1/4, if we do cos inverse of 1/4, it will undo that and find out what we put in to start with. So we go to our calculator, make sure that we're in degrees. Second cos of 1/4, 75.5, and I think this question said to the nearest degree. So our reference angle is 76 degrees. Let's write out our positive answers. If the reference angle is 76 degrees and we look at our first diagram here, what's our actual angle? 76 degrees. Don't you wish math was always that easy? It's exactly the same. The one in quadrant 4, you're going to have to do a little bit of math. So look at the picture in quadrant 4. And I really find that the diagrams really help you see why you have to do certain things. So if you know that that little green reference angle is 76 degrees, how are you going to figure out what theta is that starts in standard position, goes all the way around, and runs into that terminal arm? We'd have to go 360. Can you see that if you went 360 would be all the way to here, and then you subtracted 76, or your reference angle, you would get exactly what theta is. So 360 minus 76 degrees is going to leave us with 284? And those will be our two positive angles. What do we have left to do? We need to find out what our two negative angles are. Again, one of the things that you're going to do as a check is you're going to find out that, I'm going to say 80% of the questions ask you between 0 and 360, the same as your grade 11 questions do. And for almost all of our questions, the first thing we're going to do is solve it between 0 and 360 once around. One of the things you always have to do when you're doing these questions in the end is check, is that all that they wanted, or did they want more answers? And so the domain here says from negative 360 to 360. So we need to find all of the negative angles that also end in those places. So if I think of standard position negative angle, can you see there would be this one? And can you see in this one it would be like that? Of those two, which one do you think is easier to figure out? The one in quadrant 1 or quadrant 4? Quadrant 4. Can you see it's the same as your reference angle? Okay? So one way that I can do that is just from my diagram, I can see that that one's going to be negative 76 degrees. Another way that I could figure that one out, since I know that this negative 76 is coterminal with the 284, I could take 284 and subtract 360, and it should end in the same spot. For the second one here, this first picture, this bigger negative angle, how would you figure that one out? You could do 360 minus 76. Now, so, right, or 76 minus 360. So you could do the coterminal. I could say I could start at 76, I could subtract 360, and that would give me that angle. The other thing that I like to do with negative angles is do them the same way that we do positive angles. In other words, when I'm doing the negative angle here with the first picture, can you see it's like going 1, 2, 3, 4 quadrants in the negative direction? So I think of it, how would I do that if I did 4 quadrants in the positive direction, like I did over here? I went 1, 2, 3, 4 in the positive direction. How did you figure out this angle the first time? You said all the way around is 360, and then I subtract my reference angle, and I would get the answer. So I do that same sort of thing in the negative. I say, well, all the way around is 360, and I actually don't worry about negative 360 at this point. I just, it's better to think positively, right? So, especially when doing math, because sometimes you can get really down if the questions get hard. So I think positively, all the way around is 360, and then if I just subtract my reference angle, that would be the same. Well, I already know that 360 subtract my reference angle was 284, so the answer will be 284 again, but this time it's negative. So you could either get that negative 284 by taking 76 and subtracting 360 once, because that's a coterminal angle, and that's something that we've learned. Or we can take our idea of reference angle and figure it out from there. Question 9, 10, and 11. And if you want to put a star beside question number 4 and go back and put a star beside question number 3, as far as importance goes, these are two very, very important questions. You will always get these questions on your final exam in some form or another.